Okay, this is the third lecture over Chapter 3. It goes with 3.4 in the book. Cycling maintains homeostasis in the environment, keeping everything in balance. I think the book talks about 4 different cycles. We're going to just talk about 3, the water cycle, the carbon cycle, and the nitrogen cycle. The water cycle. The water cycle contains evaporation, transpiration, condensation, and precipitation. As you know, evaporation is water evaporating from lakes, ponds, oceans, rivers. It evaporates into the air. Also at the same time is transpiration. That's water being lost from plants, kind of evaporating off of plants. Again, into the air, all of that evaporated and transpirated water condensates to form clouds, and eventually the clouds lead to precipitation. So it's this continuous cycle. The amount of water on Earth never changes. The amount always stays the same. The Earth does not produce more water. So if we do pollute the water, we have to find a way to clean it because we can't make more. But there's the water cycle. Then there's the carbon cycle. Photosynthesis and cellular respiration are what cycle carbon and oxygen through the environment. And we have that formula that was in lecture 1, and the formula that's on the board talks or shows you the carbon cycle. So if you look at the board, you have oxygen plus glucose makes carbon dioxide, that's where the carbon's stored, water, and then we get the energy. Photosynthesis takes the sun's energy, takes some of that water, and takes that carbon dioxide and forms glucose and oxygen. So the carbon cycle includes the cycling of carbon and carbon dioxide and the oxygen. And then this is just kind of a picture showing that. Animals, plants, detrivores go through cellular respiration and will release carbon dioxide. Okay. Photosynthesis takes in carbon dioxide. Herbivores eat the plants and so forth. So this is like the whole cycle. It deals with cellular respiration and photosynthesis. One other thing, I guess, that's also releasing carbon in the atmosphere are like factories when they burn fossil fuels. So that's another way carbon dioxide can be released besides cellular respiration. And then the nitrogen cycle, there's atmospheric nitrogen, makes up about 70% of our air. Organisms cannot use it in that form. Lightning, when it lightnings, bacteria can convert nitrogen into usable forms. So when it lightnings, it takes the nitrogen from the air and puts it into a usable form, and plants use nitrogen to grow. Only certain bacteria and industrial technologies can fix nitrogen, make it so that it can be used by organism. Nitrogen fixation is what it's called. They convert atmospheric nitrogen into ammonia, which can be used to make organic compounds like amino acids, which then plants use. So nitrogen-fixing bacteria, some live in a symbiotic relationship with plants of the legume family, like soybeans, clover, peanuts. So on the roots, there's this nitrogen-fixing bacteria taking nitrogen from the ground, and then the plants use it to grow. Beans take in the nitrogen, or make nitrogen, and they use it to grow, and they're also releasing the nitrogen into the soil, so we have nice nitrogen-rich soil. Now corn, on the other hand, sucks out the nitrogen out of the soil. So if you planted corn year after year after year, your soil would not have enough nitrogen in it, and then your plants will not grow very well. That's why in places where they plant corn and beans, they do crop rotation. One year they'll plant the corn, it'll take the nitrogen out of the soil. The next year they plant the beans. The beans have those bacteria on the roots, the nitrogen-fixing bacteria, and can put nitrogen back in the soil. Some nitrogen-fixing bacteria live free in the soil. Nitrogen-fixing cyanobacteria are essential to maintaining the fertility of semi-aquatic environments like rice paddies. Kind of the same thing going on there, keeping the paddies nutrient filled so the rice can grow. This is just another chart to show the nitrogen fixing cycle, the nitrogen cycle. Again, we have the atmospheric nitrogen. Lightning can change that into a usable form for plants. You have the nitrogen fixing bacteria, which will make the ammonia. Nitrification by bacteria. You have nitrates making more nitrates, which then the plants can use and the plants grow. The ammonia can be used directly by decomposers. And of course, if we have plants growing, we have our oxygen, we have our glucose. That is definitely needed by us. So the nitrogen cycle is very important.